Okay, welcome to this video lecture, and today's topic is Ohm's law. Before going through the blackboards, might be going to explain you what Ohm's law means. As Ohm's law states that at a constant physical condition, these physical conditions are mm, mechanical strain and temperature and etc. like this. Okay, basically in your class it is of temperature. So at a constant temperature, the current flowing through a conductor. Basically, we are going to talk about a conductor. So a current flowing through the conductor is directly proportional to the potential difference applied across the ends of the conductor. I repeat, the current flowing through the ends of a conductor are directly proportional to the potential difference applied across the ends of the conductor. Remember that physical conditions like temperature, mechanical strain, etc. are kept constants. Okay, so basically what Ohm's law says that I is proportional to V. Okay, or we are going to say the current flowing through the ends of a conductor is directly proportional to the potential difference applied across its ends. Okay, just rearranging this factor, or I be going to write V proportional to I. We may write it like that. I will explain it later on. V proportional to I, and then we are going to write it as V. On the removal of sign of proportionality, we will get a sign of equality. Should be a constant that we call R. So it is V equal to I R, where this R is a proportionality constant that we call resistance. Okay. If the next question that comes in our mind, if graphical representation of this, the graphical representation of the Ohm's law is, as we are going to increase the potential difference across the ends of a conductor that we simply going to say through which current electricity can pass easily. Okay, so suppose there is a battery arrangement. This one is the battery arrangement. This is a connecting wire, or I be simply going to say it as a conductor. Okay, so as the battery potential or the battery voltage, we are going to rise it up. Okay, I'm going to replace a battery. Suppose first we are going to take a 5-volt battery. There should be a current I flowing through the wire. Okay, if I'm going to increase this 5 volt to 10-volt battery, I'm going to replace a 5-volt battery through a 10-volt battery, then what will happen? I will see that there should be a increase in the current. The current is going to be increased. That is the simple meaning of Ohm's law. Okay, so I is proportional to V or V proportional to I. With this explanation, I will going to explain you that as the potential increases, the current through the conductor is also going to be increased. If I'm going to plot a graph between these two, we will get a straight line. Okay, this straight line represents that the potential and the current ratio will be same throughout. But remember, the temperature, or simply we can say the physical condition, will remain constant. Okay, now let's know more about this. How physical interpretation of that much of figure. Suppose there is a tunnel, okay, and we have to pass something through this tunnel. The narrower part on this tunnel is being represented by this resistance R, okay, and the amount of flow or the push or the power that will provided to this end to pass something from this end to that much of end. That power we are going to represent it by a voltage or a potential. Okay, so something that is going to be pushed through this side is a potential that we are going to represent it by a potential, and that will pass over through this narrower part. We are going to say it as current. Okay, so what will happen as the this value V, this potential, we are going to increase this potential. What will happen? The I will increase, but there should be an effect of this R also. If we are going to increase this R, what will happen? With increase in R, this portion will become more narrower, and with this kind of a effect, what will happen? This potential, whatever it be the potential, but there should be a lesser amount of current to this side. So this explains that with rise in resistance, the amount of current will decrease for a same potential that we need to understand. So I be going to say that the resistance increases, the current will decrease for a same potential. Okay, so you need to remember this line, that with rise in resistance, the current decrease for a same potential. Converse of it, for a same potential, if the resistance is going to be decreased, the current. Let's continue the Ohm's law topic. This time we are explaining the graphical representation of Ohm's law. Okay, so here the graphical analysis of this Ohm's law. There are the two graphs. One is between V and I, another is between I and V. Okay, if first go through with this graph, that's the first graph. If you see, there is a graph between V and I. If I ask you a question, what does the slope of this graph will give? So you know very well the slope is equal to tangent of the angle. Okay, and that tangent of angle is equal to perpendicular over base. That this time the perpendicular, if we go through this angle, the perpendicular is that much of side. That much of side is V. Okay, and the base is that much of side, that is I. So the perpendicular over base is equal to, if we see with this formula, Ohm's law, V by I is equal to R. So this will represent R. Okay, so with this graph we know about the resistance of the wire, okay, or the conductor. Similarly to this graph, if we see, this is the graph between V and I. If I ask you this time, the perpendicular is I and the base is V. So I over V is equal to, if you just reverse that much of expression, you will get the value 1 over R. So this will give 1 over R. Okay. So slope of that much of graph will give 1 over R. Okay. Now let's move to another section. If we have, suppose, two wires, that one is A and this one is B. Okay, and this side same wire A and B. If I ask you a question that which of the two wire A and B in both of the graph, this is first graph and this is second graph, will have a higher resistance value. So how will you know about this? As we said, this side it is V by I is equal to R, and this side it is I by V is equal to 1 over R. Okay, so which one will have a greater resistance? They will have a greater V over I ratio to this side. Who will have a V over I ratio in a large amount? If you see a constant I, for a constant current, you see the voltage of that much of graph. Okay, the voltage of this VA, this that we are going to say as VA, and that much of voltage we are going to say it as VB. Okay, so VA is larger than VB for the same amount of current. So we understand that A will have a higher, RA will be higher than RB. Okay, RA will be greater than, or are we going to write this much of the resistance of A is greater than resistance of B. Similar to this side, if we come to this side, we will see that the resistance this time this ratio is I over V, and that will be equal to 1 over R. So for a larger value of resistance, the factor 1 upon I will be lesser. Okay, this factor will be lesser, and if this factor will be lesser, that much of factor has to be lesser. Okay, so we need to lesser that much of amount for calculating the greater resistance. Okay, so just understand this concept. So as we see that I upon V, for a greater resistance, 1 upon R should be lesser, or we can say I upon V should be lesser. So out of these two graphs, which will have I upon V lesser amount? So I think B will have a lesser amount of I upon V, as we see, as for a constant voltage, you see that this current is IA and that much of current is IB, and we see that IA is greater than IB. Okay, and if IB is lesser, this factor will be lesser. Okay, that much of factor will be lesser and R will be greater. So this case RB is greater than R. Okay, so I think you will understand that kind of a. Okay, let's continue the next topic of the Ohm's law, that is resistance. Okay, last time we have done the V equal to IR, and that R should be the resistance. So let's know about that resistance. Okay, so this resistance, what we know about this resistance is, it is a property of a material. It is the property of a material that through which it is going to oppose the flow of electricity. This is basically a opposition. It is basically a opposition offered to the flow of the current, that we call resistance. Okay, and resistance, we are going to calculate it by a factor R equal to V over I. If 1 volt of potential is applied across the end of a conductor and 1 ampere of current is passed through it, so we are going to term it as 1 ohm resistance of the wire. So ohm is the SI unit of the resistance. Okay, so now on knowing the resistance, now come to the factor that affects the resistance. Factor affecting resistance, number one is length of the conductor, and how this length will affect the resistance is that R is proportional to the linear power of length. That means with a unit change in length, there is a unit increase in resistance. As that length increases, the resistance also is going to be increased. Okay, second is area of cross section of the conductor. We see that R is proportional to 1 over A. Okay, that means with increasing area of cross section of the wire, the resistance is going to be decreased. There's an inverse relation between A, that is the area of cross section, and the resistance R. Third is the temperature of the conductor. The temperature of the conductor, as the temperature of a conductor is going to be rise, as you know from the Ohm's law definition, or Ohm's law statement. That statement is at constant temperature. That's why we are going to talk about the constant temperature. As the temperature is going to be increased, the resistance of the wire, conducting wire, is going to be increased by a factor that much. This is the temperature. This is the resistance at temperature T. This is the initial resistance, and we see that the initial resistance is a factor of 1 plus something, and that alpha should be positive for a conductor. Okay, and this is the temperature difference between initial and the final state of the temperature. So with at temperature T, it should be R naught times of 1 plus of something. If we are going to multiply something with a factor of 1 point something, the value will be larger. Okay, so that's why we are going to say that for a conductor, alpha is being positive. So with increase in temperature, the resistance is also going to be increased. And fourth one is the nature of the conductor. It depends upon, is it the wire. It depends upon the nature of the wire. The wire is of copper, aluminum, silver, etc. Any of these may be the example. Okay, so these are the factor affecting the resistance. So this is done for the day. Next day we will continue the resistivity. Okay,